Welcome.
To the joy of coding.
Hello, and welcome to episode 72 of The Joy of Coding. My name's Mike Conley. We're going to be hacking on some Firefox stuff. We're going to be down in deep in the guts of Gecko using a tool called RR. We're going to start investigating things at a very low level for a particular type of bug. I'll tell you all about it in just a second. I just wanted to say hello, and I hope you had a great week since last we saw one another. So what's going on today? What is going on? Boop, that's my screen. Boop, here's the agenda. So here's the idea for the folks who are new. I say this every week, and I'll say it this week as well. There's no plan really for these episodes of The Joy of Coding, except that there kind of is a plan. Like, there's a vague outline of the sorts of things that I like to do, or that I want to do, but nothing ever goes according to plan in my experience. And so I just want to remind you that even though there's kind of a layout for how things might go today, that no plan survives breakfast, and it's quite possible that I will go completely off the rails, get distracted by something, we will get involved in some other emergency or some other mess. So just be prepared for that. Quick self-check, make sure that I'm recording. Yes, I'm audible. Yes, sounds work. Yes, and let's get going. So this agenda that we're looking at here, I'll also point out, there's some useful stuff in here, some useful links, especially if you want to follow along. And it's probably only useful if you can actually click on those links. And you can click on those links because this agenda is available to you. If you're watching this on Air Mozilla, you can scroll down. There is an additional links section, which should have a link to this agenda that you can follow along with. And if you're watching this on YouTube, that'll be in the video description. And then you can click on the links and you can follow along. So, what are we doing today? Well, we actually tried doing this a little bit last week. Where we were investigating an intermittent orange. I explained that last week. I'm going to explain it again kind of this week, where basically we have a type of test. We have these automated tests that run on Firefox. Every time you push a patch into the repository, we run this humongous battery of tests, absolutely humongous. And some of those tests will pass sometimes, but fail other times, even though nothing has broken. So for example, suppose I push some empty change set to Firefox. So nothing has changed, and I run the tests. Sometimes the test will pass, but then if I trigger those tests again, sometimes the test will fail. And so what we call these are intermittent oranges, because orange is how is what we refer to as a failure in our for a test in our testing suite is an orange. That's the color code it's given. And so this is an intermittent orange, or an intermittent test failure that we're talking about here, and we're plagued with them. I mean, if you look at like Tree Herder, which is the tool that we use to watch our trees, and I'm looking at Inbound, which is one of our integration branches, you can see that periodically these oranges will come up, and sometimes these oranges are legitimate failures, but sometimes they're not. Sometimes they're intermittent failures. Like this BC5 is starred. It's got a star here, and it's because that there is a intermittent. An intermittent has been filed for this particular test, for this particular error, and so that's something that we just have to deal with, unfortunately. And the more we can get rid of these intermittents, the better. And that's what I'm trying to do today, is get rid of one of these intermittents. Not this one, although this one just caught my attention because I wrote this test. And so I'm curious about how frequent this is. So here's a perfect example of me going off the rails. I want to know what line 206, because that's the failure, that the failure is happening at 206, and I want to know what is happening at that line for this test. Line 206. Line 206, there's nothing at that line. Uncaught exception at 206. Node was not found. Just going to take a quick peek at this test log. Test unexpected failure. Node was not found. Oh, it's in notification 206, but in the test it's in line 499. 499. 499. That's right here where we're attempting to remove a notification. And it's not assert throws. What does this test do? Shutdown while not showing. So we create pending crash reports. We make sure that notification is showing. We get rid of the notification by closing it. Oh, yeah, we shouldn't even need to do this. Removing the notification should not be necessary because... Oh, but then we uninit, and then we init. Then we should also... We should probably add a wait here to make sure that the notification shows up, because there might be a little bit of a race here where the node is not found or the node's not ready. Node was not found when we attempt to remove a notification. So I wonder if, yeah, there's some asynchronicity here. And someone's talking about me in IRC. Let me just quickly check what's happening in A-Team. It's true. It's true. Ted is saying that I'm going to be debugging an intermittent with RR. And let me get to it. So what? This is a completely unrelated intermittent that I'm looking at right now, but it's fascinating to me. I'm just, because I've gotten into it, I'm going to write down my findings in the bug. I think we need to wait for the notification node to show up here, and then where was that line? It was after we ignore. It was after can ignore. It was, oh man, I had it. Shutdown while showing. It was right here. Right? That's where it was? Oh, I forgot. What a waste of time. I'm sorry. I'm so sorry. It was in test shutdown while not showing, 499. Yeah, it was down here. But I'll bet you it's the same problem up here where we might end up on it, shutdown while showing. Oh, that's probably fine because we don't remove the notification. But this one, we click the notification to go away. So let me just quickly write this down, the bug. Because the call to unsubmitted crash handler .init kicks off the unsubmitted check for crash reports, which is async, so the node might not be ready by the time the test proceeds. So I need more information for myself. I'm going to fix that up later. Maybe we'll even do it in this episode. You know what? Let's add it to our to-do list for later. I'll add it as a second note here. It's like a sort of a bonus bug. But for now, let's get into this other intermittent orange. So we worked on this last week, and what was up? Well, we're not sure. I started to do some investigation, and I wrote some stuff down that might be interesting to go through again. Specifically, well, first of all, I should point out, this is a particularly bad intermittent orange. This is one that's happening, pause that. This is one that's happening, it's like 19, like 2 days ago it was 18 repository, or 18 failures. Yesterday it was 19, so it's something like 18 or 19 or 20, and on the order of like almost 20 failures per day. Here it's 22, 15. There's a bit of a range, but let's say it's about 20 failures per day, and that's something that like that's adding noise to the. It's okay, Ted. I saw that Ted was sorry for interrupting the live stream. Don't worry, Ted. That adds noise, these failures. So let's get into figuring out what this failure is all about. Let's stop delaying. So BZ, who's one of our outstanding engineers here at Mozilla, looked at the test and he thought he saw where a race was, but whenever I got rid of, well, let's take a look at the test file. The test file is, oh, I can't believe I don't have a link to it. The test file is here, this one. I'll show you. There are two parts to it. There is this main test file, and then there's this like HTML page that it loads, and that's this one. And this is the where the race is that that BZ thought he caught, and he probably did catch one, but I don't think that's where the problem is. So I'm gonna sort of summarize what we're looking at here. Basically, what this test does is it opens a new tab, it loads up this page. Then this page, what it's going to do is it's going to load some iframe, and every time the load event fires, it's going to like send that iframe to a new page. And then we wait for that to occur like 5 times, and that should add new history entries. So after we see 5 new history entries come in, then we're done the test. That's what we're testing for. We're testing that new history entries are being added by this page that's updating an iframe. And the race that BZ saw was here. This set timeout here is what's being used to kick off the so this this function next is fired in 2 places. The first one is here whenever we see that like an onload has occurred, and here we see it whenever just like whenever the page is loaded, we do a set timeout and we'll run it next. And what this next what this next function does is it will check to see whether or not count is less than 5, and if not, then it's going to set the iframe source to be this data URI and then increment the count and make the count part of the URI so it's like unique. And the race that BZ saw was that because an iframe, whenever it's first injected into the DOM, because that's what happens here, is we create the iframe dynamically. When it's injected into the DOM, there's an about blank that initially loads in that iframe, and that about blank load might end up triggering the load event to fire, which we'll call next. But that might also happen. That might happen before the set timeout fires. Like there's 2 ways where we might call next. One is in the set timeout, and the other one's when the onload fires or the load event fires for the about blank that initially loads. So we might actually enter this twice when we don't expect to. So that's the race that BZ thought he caught. And what we did was we just got rid of the set timeout down here and depended on the about blank load to kick off this sort of like to kick off calling next. But I pushed that to try and it didn't fix it. The failure was still there. So the good news is that I was able to capture the failure in RR. I have a recording, and we're going to look at that recording. So this is probably what most people are interested in. I'm sorry it's taken me like 15 minutes to get there, but we're going to be looking at RR again. We did this a little bit last week. We're going to be doing it again this week. I'm signing into the Linux box where I reproduced the problem, and let's check it out. I've got an old screen session here that I'm going to resume. So yeah, we had our test timeout. That's the thing we wanted. I've got the entire output is in run.log, and that's important because I think what we desperately need is the information about which content processor, what's the process number of the content. Whoops, we're going to open read only. What is the process number of the content process whenever the failure occurs? So let's find our first failure here, the first time we report it. Test timed out right here. This is this big verbose log. And already I can see that 19481 is one of our process IDs, but I have a feeling that's the main process ID. Usually the main process is the one that's like louder, like where we see more spam. And then there's another one here, 19384, and that might be our content process. Let's see if we can prove it. Oh, it actually might be 19481. It might be 19481. 19384. It'd be nice if there was like child 19481 is the child process. Okay, so that's what we want. We want 19481. So that's what we're going to look at, that process. And there's a command that I've forgotten that is in the documentation for RR. And usage, yeah, RR usage. For making sure that when we replay, we wait for a particular process. I think it's something like run debugging a child process, replay, and then -f PID to attach GDB immediately after the fork. Replay to attach GDB to a particular process after its first exec. Okay, let's do this one. RR replay -P and then the PID. I'm also going to start taking notes. So 19481 was the name of the, or was the process ID. So let's put that in here. So new RR session. Here, let me bump up the font. Boop, 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 boop. New RR session. And the child process content process ID is 19481. And that means that the parent process, in case we want it, main process ID is 19384. And then the command for replaying is this. So I'm going to just put that in here so I don't forget. So it's RR replay -P, and then the child process is 19481. We're gonna hook that up. So here we go. That's happening now. So now a bunch of stuff's happening. Okay, so now we're at the point where 19481 was hit, or what first spawned. It first ran an instruction. And this is where I realize now that I've kind of screwed us a little bit. It's not a big deal, but one thing to keep in mind is if we look at the log, I think I had the log open in a different screen here. Yeah, if we look at the log, there were 71 runs of the test, or 71 assertions. And that means that the test, because I was running the test a bunch of times, and it's only the last time that we care about. So what I really need to do is I need to wait until we reach our timeout. And I wonder if I made it easy to detect the timeout. I think I did. Let me quickly, yeah, what do I want to do? I want to look at the difference that I've put into the file, where if we time out, I think I put in something I call math.sign in the parent process. That's not so useful, thinking back. Maybe it is. But what I'm going to do is I'm actually going to continue until we are killed. This is kind of a pain in the butt, because this might take a couple of minutes. But in the meantime, maybe we can work on a patch for that other failure. So I'm going to continue, and so the test is going to be replayed, and we're going to eventually reach the point where the test says we've timed out, and we'll kill the content process. And what we're going to do is we're going to work backwards from there to the last time that the test ran, because that last time is the one we really super care about. Because everything up to that worked fine. It's only the last little window. So I'm sorry, I should have probably had myself prepared in advance to be at the very end of the test run, but hey, joy of coding, nothing goes according to plan. So sorry Ted, sorry Will, I know there are a couple of people who are watching this who are really hoping we'd get into the RR stuff right away. I'm going to have to put a pause on that while this thing goes right to the end. Look, it's done one run of the test already, so this shouldn't take too long.
Mamma mia!
But it's going to take a couple minutes. So I'm going to have this bake in the background. Boop, 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 over there. And then, in the meantime, maybe we can crank out a patch for that other intermittent and be good citizens for the tree. So what did I find? Yeah, I have a a test that I added here at this path browser modules. Test browser unsubmitted crash handler. This is the test. I'm actually going to open this up in Sublime, not Vim. And the place that I saw the problem was on line 498. That's down here, 498, 498, right here, because what goes on is, so here's what this test does. I added some documentation. We have this unsubmitted crash notification thing that we show if we've noticed that you've got crash reports hanging around in the background that you've never submitted, and we go looking for them, and we do this off main thread stuff to see them, and then if they exist, we'll show you a notification to give you an opportunity to send them. And I'm testing that if the handler is uninit after the notification has been closed, then we assume that this pref is not set. Right, and the reason we do that is because we want to detect the case where it's shut down without being closed, because if the user shuts down their Firefox without interacting with that notification more than a couple of times, we'll assume that the user doesn't care and we'll stop showing the notification. That's something that UX asked for. I think it makes a lot of sense. We don't want to show notifications to users that don't care about them. So I think we wait something like, we see the notification over 4 different days and the user has not interacted with it over those 4 days, then we just suppress the notification for like a month. So that's what this is testing, the sort of converse of that, where we make sure that if the notification is interacted with, if the user just says like I don't care or clicks on anything, that the pref for indicating that we shut down while still showing it is not set. So what we do is we create some pending crash reports, we cause the notification to be shown, and then we dismiss the notification by choosing the X button. That's the dismiss button. We wait for the reports to be ignored, and then we shut unsubmitted crash handler down. We kind of we simulate shutting down the browser by shutting down the unsubmitted crash handler and then turning it back on again, which is my way of simulating a restart of the browser without actually doing it for the purposes of this test. But then when we do this, I also want to make sure that like, oh, there should be no notification at this point. That makes sense. Because we dismissed it. And we ignored the ones that we should never do this line. That's the thing. We should never do that line. That line makes no sense because the notification was removed. I'm actually really surprised that that this ever worked. But you know what it is? It's because there's a transition whenever you close, when you click on the close button, and there was a race here where the notification is removed after the transition completes, and sometimes that transition would complete before all of the stuff was done, and sometimes not. And so what we really need to do is click. We should wait for the notification to go away. Remove notification. Thing is, you don't want the notification to leak if it still exists at this point. You don't want it to leak into the next test. That will taint it. How's our R is still going? So what I need to do is just make sure that the notification is gone. I mean, I could check to see if the notification has no parent node. That's one way. What else could I do? Is there anything else I could do? I could get rid of the animation on the notification. I could also wait for the notification, not only wait for the reports to be ignored, but wait for the notification to be gone. Maybe that's what I should do. Okay, maybe that's what I'll do, is I'm going to wait for the notification to go away. So I'm going to add a new helper. I'm going to say something like let notification gone equal wait for notification gone, and then pass it the notification, and then we're going to yield that here. This is also going to trigger the, like initting it here is going to trigger the check for unsubmitted crash reports. Async. Um, Content crash handlers. That's where unsubmitted crash reports is handled, and it's down here, I believe. Unsubmitted crash handler when we init. Oh, no. My assumption was wrong. We don't do anything asyncy after here. Okay, that's good. Whew. Okay, I'm happy about that. I was worried that after you call init, we'll immediately like init would call this async function, which thankfully it doesn't. We wait for the um, first browser window to be displayed to do that, and that is not going to occur here because we don't open a window, so that's good. So I think this will work so long as I provide this helper function. So I'm going to add a function here. Function wait for notification gone. So I'm going to return a new promise. Is there like a trying to remember if the notification before it's destroyed, if it fires like an event or something. Notifications.xml. Notification.xml. Here we go. Remove notification element. We fire this removed event on it. Maybe that's enough. And then they remove the child. Yeah, that's probably enough. So return browser test utils wait for event notification removed. That's what happens, right? Like there's, oh wait a second, event callback is slightly different. It's not an actual event. Shoot, it's a thing that like whenever you construct the notification, it's like a callback that you register with it. So this is not gonna work. This is not gonna work. How's RR doing? Again, I apologize if you were waiting for RR. We're gonna get there. We're gonna get there once it reaches the end. Hopefully, I don't have to do this step too many times. That takes forever. I think browser test utils is something like wait for condition. Yeah, wait for condition. Condition, and then we're gonna wait for waiting. What's the message? The message. Reject. Okay. Timed out waiting for the notification to go away. And the test is notification return notification.parent node. Cool. So let's add some documentation. Returns a promise that resolves once a notification has been removed from the DOM. Zool notification node has been removed from the DOM. And then it takes a param of notification of Zool notification. the notification that we expect to go away soon, and then returns a promise. Okay, so now let's run that test. Mock, Moki test, browser, modules test, browser, unsubmitted crash handler. Hey, alright, we passed. I feel pretty good about that. I'm gonna just re-examine the diff that we created. This font's probably too small for you. So yeah, I add that helper function. Cool. Now, are there any other places in this test suite where I dismiss the notification and need to wait for it? Let's quickly check. Do I click on anything, for example? No. What does this test do? No. Test that if set, we don't suppress, no. Okay. Just chooses to dismiss the notification. So we should probably do that here. Let notification gone equals wait for notification gone. Notification yield notification gone. And wait for ignored reports. What is that again? Wait for. Right, it's going to return a promise once that resolves once all of the .ignore files exist. Okay, notification gone. So that's one. Notification. No notifications displayed. Test that send always. So we check for notifications, send all, wait for reports. We're going to click. Oh, we'll not wait for the notification to finish its transition. We'll just remove it right away. Maybe that's what I should be doing instead. You know what? I think I prefer that other solution. Yeah, of just removing it right away whenever you, instead of polling and hanging around. Wait for notification gone. I think I like the idea of just removing it. So where else did I use it? Wait for notification gone. Here's another one. Nothing else. Okay, so was there anywhere else where we like dismiss the notification? Should be no notification. Test one pending. Should be a notification. We remove the notification here. Should be a notification. We remove it. Notification. Then the several can submit. Remove it right away. Remove it right away. Remove it right away. Okay, so let's try that. How's Hawkman doing? Still going. Whoa, failure. Failures across the board. What happened? Unexpected failure. There should be no notification if we've run out of chances. Oh man, I think I broke something. Let's run that again. Okay, I think the problem is that I accidentally had the wrong window focused when I ran the test. Normally it's not great to have a test written like that, but we're talking about notifications here. Okay, so happy with that. Hopefully RR is going to be done soon. Let's put this up for review. Um, bug. Remove Zool notification right away in browser unsubmitted crash handler to avoid intermittent Florian. Florian reviewed the original test, so I figure he can review this quick thing as well. Okay, and we'll push that for review. And then let's move on to the next thing. Oh man, this is taking a lot longer than I expected, RR. But, I mean, that's how the cookie crumbles. Come on. Where even are we in this test run, I wonder? Serial 673. I wonder if that's like... No, I don't know if that's the number I can count on. Maybe some of these memory addresses, though. Okay, well anyways, let's publish this for review. Get it up there so that we can close out this intermittent orange. Take a quick look at the patch. Yep. Okay, I'm happy with it. Okay, so that's up for review. That's done. I guess I'll take this bug. I mid-aired myself. Take it. I guess this is one of the problems where if you've been using RR to debug a failure, an intermittent failure, and the way you triggered it was by like running a bunch of the test, maybe you repeated it a bunch, or you had to run the entire suite or something. It's knowing kind of the range or the event time, like, because I think RR has a notion of event numbers, and so like every time either of the processes ticks forward, I believe there's an event number that's recorded, and knowing what that event number is, I think really helps because you can fast forward to those numbers, and you get like it's like fast forwarding into a videotape or a DVD for the people who remember what those things are. Okay, so while we're waiting on that, that's done. Hey, wrote a patch. That was unexpected. I guess we'll work on this other thing, which is other test failures. This isn't an intermittent test failure, though. I'm actually going to rebase this patch onto Central, because I think I based it off some of the work that we're about to go into. But that doesn't really affect the patch for Florian's review anyways. Okay. So now, yeah, this patch is now in Central now, and I'm going to check this stuff out down here. This is the stuff I want to work on where we're converting the autocomplete pop-up to using a rich list box instead of a Zool tree. So let's check that out. Come on, RR. I'm like, as soon as this thing ticks over, like we hit our end of process and we have our failure, I'm going right into this RR business. I know that's what some people are interested in. I apologize if this is what you've been waiting for and it's just like cooking in the background. I That's what happens. The serial number keeps escalating. It keeps going up. I wonder if we can use that as a clue to figure out how far we are from being done. Um, is there run.log open read only test timed out? Serial was at 1257. We were in that range. 1257, 1267. So my guess is if we're at like in the 800s, we're like maybe another 5 minutes away. That'd be my guess. Because that number is escalating quite a bit. We're almost in the 900s. And if we need to get into the 1200s, well, we are almost there. So stay positive. Stay positive, people. We're almost there.
Mamma mia!
I'm going to play like a big victory barrage of sounds whenever RR hits that point. In the meantime, let's take a look at this other test failure that I'm dealing with, which is in here. I've got this Moki test Chrome test called test autocomplete with composition on input that is failing. Whenever I switched us over to using a rich list box instead of a Zool tree for the autocomplete pop-up. Now, why is that? I don't actually know, but I can easily reproduce the failure if I run the test. Let's see. I'm getting LMAU'd by Ryan VM. I should probably turn off notifications whenever I'm live hacking, because anyone could really say anything, and like it would suddenly show up in the stream. Like security stuff could show up. So I'm going to turn those notifications off for temporarily. Okay, so we got that failure I was telling you about. So the one thing that I noticed is that when I run this test, if you look at it, is that it takes a while. Like, it doesn't take too long, but it takes, let's see, 1, 2, it's been like 4 seconds, 5 seconds, 6 seconds, 7, 8, 9, something like 10, 11 seconds to do the job. 10 or 11 seconds to do the job, that is way too long. If we could cut that down, that would really help me sort of nail into, or like get a better sense of maybe where the problem is. No, don't do that. What'd I do? What'd I do? Armin, what did I do? What'd I do? What did I do? What do I need to stop, Armin? Armin just said in IRC, oh, disable the notifications. Oh, well, I don't want people to all of a sudden dump like the worst case scenario. Armin's complaining that he can't bomb the show anymore. I guess what I don't want to happen is for someone to be like, hey, here's this big security issue, and then they send it to me over IRC and it shows up right during the live stream. That'd be terrible. I don't even, that's never happened during a live stream. I never want to, I never want that to be the case. Uh, yeah, there is a lag, Armin. I'm sorry. That's live television. Hey, we're in the 1000s now, so if we're trying to get into the 1200s, I'm gonna say The next 2 or 3 minutes, we're gonna have hit our RR thing, and we can keep going. So in the meantime, this other test that I was trying to debug, it took 18 seconds to run the suite. Let's see if we can trim that down a little bit. Let's take a look at this test. So the test is using sort of this older mechanism where, or like a sort of a homebrew testing object thing that has like this test array on it. Um, and so the first thing I might try and do is get rid of some of these tests, like just comment them out. So we'll keep the housekeeping one, but let's comment out these, all of those. Really, all we need is any of the ones where the pop-up is true, actually. Could take. Um, so true here, false here. I guess that's okay. Oh, actually, we can go earlier because there's a true up here. Is that the earliest true? Yes, it is. So let's just disable all of those tests. So there's just these like 3 tests at the beginning. Let's see how much we've shortened our test length down. Ooh. Oh, almost there. We're almost in the 1100s. So I brought it down by 7 seconds. It's still a long time, but let's see if we can bring it down even more. Composition change. Is there any are there any set timeouts here? What synthesizing composition change start length caret clause string composition. I don't see any of any set timeouts. There's some wait for condition here. Maybe that's it. Composition, modifying composition string shouldn't open the pop-up. Composition end should open the pop-up. So should I size composition change? Can I move this into here? No, you know what? I should just keep it this way. 11 seconds. I don't want to mess around with the test I don't understand too well, but 11 seconds isn't so bad. We brought it down by 7. Let's see if we can work with that. So what is going on in this test? Well, it's weird. At the very beginning of the test, we do this thing where is it? It's actually in the other testing file. We use the special powers API to get the form fill controller. That's this global form fill. I think it's process wide singleton. We get it, and then we query interface that to an input, and then we say, oh, that's all unrelated. This is the important part. We're attaching the form fill controller to something. So the form fill controller is one component, and the autocomplete pop-up is another component. And when the form fill controller says, hey, I need an autocomplete pop-up, or I need to open some results in a pop-up, it will then hopefully be attached to a pop-up, and then the pop-up can show the results. And attach form fill controller to is the part where we connect the pop-up to the form fill controller. So let's take a look at, I think I've done this before. Let's take a look at this implementation of attach form fill controller to. How are we doing? We're about to enter the 1200s, folks. I wonder if maybe we should just sit back and watch and see if I was right whenever this test is about to fail, or we're just about to time out. We might actually be in the timeout right now. We might be waiting for the test runner to say, hey, you're taking too long. No, not yet. But we're in the 1200s now. And I don't even know how long the timeout is. We might have to wait Even though we're in the 500 or the 1200s, we have to wait like 5 minutes for the test framework that was running to say, oh, it's taking too long, and then kill the process. So many complications. I was hoping to get more done by now. Story of my life. So back to this first test, or this other test. We get the form fill controller, so we get that singleton I was telling you about, that service thing, the form fill controller. And then what we do is we call attach to browser on it. And attach to browser, if we look at the definition of attach to browser, takes a dock shell and a pop-up. And if the dock shell, like we'll start paying attention to key presses and stuff in the dock shell, and if we start noticing that some of the form fields have matches in form history, then we'll open the pop-up in the pop-up that's passed in. And so that's fine. We're connecting to the Windows dock shell. In this case, the window is a top-level Chrome window, I believe. I think. Might be wrong about that. Get dock shell. No, I think it's actually the sub. It might be the iframe that the Chrome tests run in, something like that. But we get the dock shell for it, and then we connect that to the autocomplete pop-up of the window. And if we look at get autocomplete pop-up, what it's doing is it's getting the top-level Chrome window, that's the outer browser window, and gets the pop-up autocomplete. And that's the thing that I've been messing around with. If we look inside the patch, like, oh, hey, we hit it. Okay, sound effect time.
That's right.
Oh, yeah.
Hi-oh! Hi-oh!
All right, we hit our sig kill. We've reached the point in the test where the test framework said, "Hey, you've timed out, so off with your head." And we can work backwards from here to the last run, the one that failed for us. So
Here we go!
quite pleased that we got here. I'm glad that didn't take the entire episode. That would have been heartbreaking. Okay, so what tools do we have? So I'm in RR right now. I'm right at the end. I have to work backwards. And I can do that because I've actually instrumented the patch with some little tricks to make it easier to detect certain things. Like, let's see. I've got like iframe.source. When we set this, when we set iframe.source, we're going to be loading a URI in a dock shell. So I could like set a breakpoint for loading a URI in a dock shell, and then yes, that's true, Ryan VM. I can always have those sound effects ready to roll. I could always become a wacky morning DJ. Um, I can set a breakpoint on the loading of the URL, and then for the, I'll just go back to like the last 5 because that's what we load. We load 5 URLs. So let's set a breakpoint. Let's set a breakpoint at ns-dock-shell load URI. Let's reverse continue. So we're going back in time. Reverse continue, reverse continue. And that, like, I don't know what RR needs to spin up in order to run, like, backwards, but, like, it takes a couple of seconds for it to, like, kind of compute what I'm asking of it. GDB and RR are working hand in hand to make this amazing wizardry happen. This kind of time travel debugging is something that, at least when I was in learning, you know, just beginning to learn C and C++, I would have killed for this. I would have been so happy to have someone just drop RR in my lap, but it exists now. Hey, okay, we hit the last load URI, which is hopefully the iframe load. So we can actually double check that by inspecting the URI itself. So let's take a look at it. So it's an NSI URI, and I will dereference that. And this is where it gets a little tricky. converting all of these like XPCOM things into something I can actually examine. So this is actually an NS nested about URI. So this last loaded URI might not be one I care about, but let's check it anyways. So let me cast it to NS nested about URI, and deref. So this is an about blank is what we're looking at right now. That's interesting. We loaded an about blank. Why? If we look at the backtrace, why did we load about blank? We loaded about blank because we received an instruction to load it from the parent process. I can see that because like tab child received load URL and the URI to load was about blank. Interesting. I don't know why that would be, but let's reverse continue. I don't think we're there yet. I don't think we're at our failure because maybe after the here's another about blank that we're attempting to load. Huh. Just to double check, this is the XRE is content process, right? Yes, okay, good. Reverse continue. Load URI. Okay, now what is this? What is this URI business? Whoops. So this is a simple URI. This is not an about URI. That's good. So let's cast it. It's possible that all this casting business I could probably do away with if I had like a better LLDB in it, or in this case GDB in it. I don't have that stuff here on Hawkman, so I'm having to do all this stuff kind of manually. But I'm going to cast to a simple URI pointer and then deref. And what we've got is a data URI pointing at, so this is good. We're at the last load in the test, the last load. And I kind of got here before, so we're in a good position. We're at the point where like this, where's the file, the test file? I guess I opened it in the browser. We're at the point where count starts at what? Count starts at 0, and it increments. So we're on the last load. Count was less than 5. We do the last load. So this is the last one. And for some reason, in this last load, we're not calling on history new entry, which is very interesting. So why is that? Why do we never reach on history new entry? And excuse me, I just had lunch. Little belchy. Working my way backwards, I'd done this before, and I had this information. It's because a load type, we say we're still busy when we're not. Like I've kind of jumped ahead, but you should check this out. This is the comment I'm going to put in the agenda for you to follow along with, because I've done some of this. I done some of this investigation earlier, where basically what's going on is I realized that we attempt to load the page. We're loading this URI, and yet we're still busy. We're still busy loading the previous one, which is weird because the load event has fired. So what's the deal? What's the deal with that? Is that still the case with BZ's set timeout thing removed? Well, let's double check. I had put the breakpoint. Yeah, this was the important part. We're accidentally setting load normal replace when we shouldn't. So I'm going to set a breakpoint at 1407 of the doc shell. Whoops. So let me just make sure that Replace still makes sense. Ns doc shell CPP 1407. Oh, we want to go, yeah, 1407. That does make sense. So MB ns doc shell dot CPP 1407, and then we're going to continue forward. So we went backwards before. Now we're going forwards. Okay, we hit our breakpoint, and we're going to see if we're busy. If we're busy, then it's the same problem as before. So we get busy. We're getting busy, and we see if parent is busy. No, it is not. Is our self busy? It is not. So we don't enter that. Huh. That's unexpected. So I'm going to reverse continue. Is it possible that we were busy for one of them but not all of them? Unload, load. So ignore that. The iframe is injected into the page. We see the about blank load. We queue up next to run. Next runs after a timeout of 0. That sets the source, and then it exits. Onload happens, set timeout. That should be okay. It's a little weird, but it should be okay. So we weren't busy, which is interesting. So then how come we don't, like, do we end up firing the on history, the add entry? Do we call into add entry then? Add child. So yeah, do we enter here? Add to session history. We do. Okay. So then what happens? We're going to step through, see what's going on. We're on 121. We see if we should persist. Are we going to persist this thing? Yep. We're going to see what the load flags are. We got 12110 is what? This stuff. If this is load flags replace history, which it's not, it shouldn't be. It should be, this is not a replace, this is a new entry. So yeah, we shouldn't be entering this. We should be creating a new entry. So yeah, we do create an entry. And then what we really want is to enter this. So let's see, let's jump down to 12264. Doc shell CP 12264. This is the root doc shell. So let's go back up a little bit. It's not quite there. Yeah, we're going to set breakpoint 12254, which is right here, which is before this big if block, this block, which contains the thing I care about, which is down here. So 12254. I don't know why the line numbers are different between here and the source. I guess maybe there's been some traffic. But continue. So now we're at 12255. So we should enter this block. Interesting. We did not enter that block. Maybe I was mistaken. Else. Oh, yeah. We're in this part. We should be a subframe. Yes, that's correct. Because we entered the else is what happened. Okay, good. Okay, now we're in business. So add child sh entry to parent. That's correct. We should be doing that. Break doc shell. Okay, continue. I hope you can see the stuff I'm writing. I'm going to pump that up a little bit more. So now where are we? We're in add child sh entry to parent, which is here. This is a little bit shorter, but ideally what we want to do is we want to get there. So let's see if we do that. We get root session history, get index, if parent, add child sh entry. Yes, that's what we want. So step into that. Okay, I add child sh entry. We're in doc shell again. Add child sh entry, which we'll probably call one of these things. Load type is push state. No. Clone ref, PA clone ref. What is that? Nope. So we're going to do add child sh entry internal. So now we're in that. We're in here. Ideally, we need to be like calling add entry somewhere. So what I'll do is I'll set a breakpoint on add entry, which is in sh history. And if we don't hit it, then we'll just work backwards and go back to where we were just now. So where are we, or when? We're at 357. That's the event number. I'm going to write that down. After having loaded page 5, I guess, in the iframe. Okay, so continue. We do call add entry. Transaction, current persist, current transaction, get persist, do create instance, do ensure true, get URI. P mraw pointer, P and S Mozilla net. I don't remember what was the casting rule. It doesn't matter. I know it's the URI of that last page. Set persist to something, create it, length. So what's the length now? 6. Okay. Whoa, but why didn't we alert anybody? We're in add entry, right? Add entry. There should be a point where we notify the listeners. So reverse step. What? What? Where am I? First continue. Okay, let's try this again. So after we get current persist, we get the URI, we should notify the listeners. Current persist, current transaction, 6386, current we're up here. Get current index, if not current persist. So we do create the instance, ensure true, we get the URI, get the attr-refs, we notify the listeners of a new entry. So we should have notified the listeners just now. Let's take a look at the log of the timeout. Test timed out. When the test timed out, how many... We saw that we were setting the source, document state is complete. We set the source to 2, 3, 4, 5. Do I have... Did I fail to add any logging to... Shoot. On history, new entry. I don't add any logging there? Oh, man. I should have added some logging here so that we knew whether or not it was being hit. That's a bummer. That's too bad. I mean, I guess I could do that and try and capture it again, but I don't think I'll be able to do that in this episode. But we did go through all of the loading and like load state. The document state was complete at each one. So we're notifying. What are my breakpoints? Maybe it's one of the previous ones. Like, we have to... I'm going to assume for a second that that alerting, like notify, worked properly. What is it? The note on history new entry. I'm going to assume that that worked properly. It got dispatched into the test. But maybe one of the earlier ones didn't. And the test is making sure that we get them 5 times. So if it didn't work for one of the previous ones, then that would explain why the test timed out. So let's look at some of the earlier ones. Let's disable some of these breakpoints and just look at load URI. So break, disable 2 to 7, or I think, sorry, that's LDB syntax. So those are all disabled. So let's reverse continue. So we're at load URI again. This should still be the same one. Mozilla Net, that's what it was. Mozilla Net, and a simple URI of loading, yeah, number 5, 205. It's actually space 5, not 205. And then we're going to reverse continue. Actually, what I'll do is I'll set a breakpoint. I'll re-enable the breakpoint at add entry, which was here, enable 7. So we should hit the add entry of the previous load next. Yes. And it should notify. Yes, it does. And then we should hit the next load, which should be page load 4. Yes. Reverse continue. Add entry. This one should be for 3. And that one we notify the listeners. 3. And here, yeah, page load 3. So reverse continue. Another add entry. And here we notify the listeners. Oh yeah, that's the same one that we just hit. We reverse continue again, load URI, and the page is 2, and then reverse continue again, and we have add history. So what's the deal? And we alert. What's the problem? Reverse continue. Reverse continue, load URI, and what's the URI? It should be number 1. And what's the one before that? Wait, is it possible that we're getting an that the value is not 5 but it's 6 instead? Count. What if it's something else? Maybe We're calling on history new entry too many times. Maybe for that first about blank load. Do we create a history entry for about blank? So we've loaded 201, reverse continue. Add entry. And this one, let's take a quick look at what the current index is. 0. We say we're replacing an entry. Interesting. We're loading a URI again. What's the URI? Probably about blank. Standard URL. Zilla net as standard URL. It's loading the full page. The test page itself. So we go to this about blank page, we load this URL, we add a session history listener. I think I know what's happening, or I have an idea about it. There's the initial load of the page itself, which is probably causing on history new entry to fire. I don't know why this. So I wonder if sometimes this is 6 and not 5. Let's count on history new entry. Okay, I have a theory. No, well, I'm gonna try a theory. Here's what I'm gonna do. My theory is that the load of this URL, the initial URL, the thing that hosts the iframe, is tainting this value. I need to duplicate history entries. History index can end up out of range. I need to understand what this bug is attempting to test, what this test is attempting to test to make sure I'm not like breaking an assumption, and then I'm going to start mucking around with the test. Because I think that might be the reason. When using Google, so this is from Jared from way back in the day, the back button occasionally stops working. Attached a short video. Bunch of history stuff. I can reproduce it on demand now. Go to there, click last, wait 20 seconds. Shaver. This test case creates two. Oh, what's this test case? In this test case, we have an iframe of iframe space 2, and then we have create an iframe set to frame 1, and then when we onload, we set the iframe source to be iframe 2. We append it. So the fix was what? The fix was what? They added a test. If the requested index is greater than the requested index -1. Okay. I guess this was the fix. And when we remove a duplicate, when load entry is called on a browser that has multiple duplicate history entries, history index can end up out of range. So I think that the initial load is uninteresting. So I think I can work with this. Here's what I'm going to do. I'm going to load the source for the test inside a content task. We change the location to be URL. Okay, here's what I'm going to do. With new tab at about blank, I'm going to have the URL go to here instead. URI spec equals URL. Oh, wait, what? New entry. I don't think the initial load of the page is what we care about. Multiple duplicate history entries. Did the commit message have more? No longer go forward. What did the original test do? It add a history listener, load a tab in the foreground. How about this? Let's load the URL directly in the tab that gets created. And then history, we count 0. Or is it because we have to wait? Count 0, history. Is it that we need to make sure the initial browser is loaded at about blank. Then we load the first one. Hey, this should be 6. Hang on. Let me just try a thing. I'm just trying some stuff. This is on my own local machine. I'm not on the RR machine anymore. Dock shell. Test browser. Where's that? Browser bug. 670. I'm curious to know if this is just a matter of a bad assumption about how many. Oh, not enough. So that's not good enough. 5. It's eventually going to be 5 apparently. Okay. So I guess we have to start out at about blank, right? Tab URL. Well, there's nothing that says that in here. There is nothing that says that. History, new entry. This test was modified to run like that though, starting out at a blank page. History listener, history listener. Then we go to the URI. Maybe we should like go to the URL, add event listener, yield content task utils. Wait for event. I think there's one. Yeah, wait for event. Subject content load. And then do that. Is that going to work? We wait for the page and then we add the listener. Except that we have to tell the page to start doing it, to kick off its thing. That's the difference. Content.wrapped JS object start. I'll kick that off. So like something like here. Function load, on load, load. No. We're going to call it start. Try that. Calling start on the wrap.js object doesn't work. Start. Content. Maybe I'll just send it a message instead. Post message. Is that done before? Content.post message. Yeah. And then post message, post message, start, stop. Stop. What's going on here? Post message, add event listener message. Toolkit components. Compartment script. Stop. Okay, window add. Okay, I can do this. Window. So function, or wait, no. Window dot add message listener message, and then if if e dot data equals start, then start. Try that. No, doesn't like. Window.add message listener is not a function, of course, because it's an event. Add event listener. What? Come on. What's wrong? Why won't you receive the message? Received a message. Window.add event listener message. That's how it works, right? It's not receiving the message. Why isn't it receiving the message? Content. Post message. That's our compartment script. Some kind of specialness. Inside a frame script. It should work. Sending message now. Maybe it's because we're never resolving a different promise. That could be. Aha, that's true. I bet this load event's happening too soon. Let load, wait for load equal that, and then yield wait for load. No. Wait for event, content, dump, loading URI, dump, waiting for load, dump, done waiting for load. What's going on here? I want to know. Waiting for load, so it... Come on, am I not using wait for event correctly? Content task utils. Wait for event, subject event name. Content task, wait for event. Utils. Wait for event, notification. Wait for event. And what's the third one? False? False for capture. DOM content loaded instead. What? Let's do something silly. Let's sleep for 5 seconds before we do anything. And sleep is function sleep, return new, promise, resolve, set timeout, solve after aim, that may, components, rcu.import resource, modules, timerages. Okay, so I've put a little sleep function in here. It's going to sleep for 5 seconds, and then it will attempt to load. 2, 3, 4, 5. What? What's happening? We don't get DOM content loaded. Maybe I'm going about this all wrong. Let test equal that stuff. We spawn that. And then browser.load URI yield browser test utils.browser loaded. Something like that. Will that work? Nope. Reference URI is not defined because it's URL instead, and I also forgot to send the message. Yield content task or content task.spawn browser null function. Content post message start. Let's try that. It's very sloppy, this test. Hey, all right, passed. Somehow. Okay, so let's see if this insano thing I've added causes the orange to go away, and if it does, then we have a legitimate theory. Like, I think we've got a good working theory on what the problem is. And the problem is that the initial load of the page is being counted in the history, like the list of history loads or things that are being added in history. So let's, oh yeah, I made these changes earlier. I'm going to shelve that for later. This patch, I think that basically what needs to happen is this test needs to be redesigned. Oh man, I didn't mean to shelve all of that stuff. I just meant to shelve that one directory. Okay, so I want to shelve toolkit content tests. Then I'm going to push this to try, and then I'm going to call it a day on this episode. We actually got somewhere. I'm surprised. RR gave us a theory. I was able to dig around in RR. We eventually got to where we needed with it. It got me a theory. I've modified the test to test that theory. and we're going to see. I'm pushing it to automation, and then I'm going to stop the episode, and we will continue next week, and I will update you and let you know whether or not that actually made a difference. So looking at HGDiff, yeah, I think that is what we're going to push to the tree. Push, so commit, bug, I'm going to give this a fix intermittent test. I don't know, Tim Talbert, maybe, doesn't matter. Somebody. And then I'm going to rebase this onto central, and then I'm going to push using the same syntax I used the other day, which triggered a bunch of try runs in that folder. But not this one because, well, maybe this one. And the build only took like 11 minutes. Yeah, let's do this one. And it just reminds me, I want to mention something during the next Firefox meeting about -- artifact. All right, that's all I wanted to do. So that's been pushed to automation. It is 2:43 p.m. and I think I'm gonna call it. Where's my soundboard?
Oh, yeah.
It is time to call it. Thank you so much for watching episode 72 of The Joy of Coding. I hope this was somewhat educational. I hope it was somewhat entertaining. I was kind of all over the map. I got sidetracked a little bit by RR, but we got there in the end. And I think we have a working theory for what the problem is. I wouldn't have been able to do that, I don't think, without RR. So big thanks to the people working on that. Rock, I'm looking at you. Thumbs up. So that's where I'm going to call it. Thank you so much for watching episode 72. If you enjoyed this episode, or if you didn't enjoy this episode, take a look at the agenda. There's a link to a form that allows you to give me your feedback on what you thought about the episode. I read every single piece of feedback that comes in. I want to know what you liked, what you didn't like, what I could do better, etc., etc. So please fill in that form. I want to hear about it. Again, thank you so much. I will see you next week for episode 73 of The Joy of Coding. Take care. Have a great week. Bye-bye.
The joy of coding.
See ya.